Hey guys, today I'm doing Google Code Jam Round 1C, and 1,500 people will advance from this round to round 2. So let's see if I'll be able to advance. There should be 4 problems, I think. Okay, the problems are loading. Okay. Oh, or are there only 3 problems? And as always, it's taking a long time to load. But there's nothing I can do about it. What if I just click this? Oh, I can actually see it. And then all the other ones are server error. I think you can iterate over, oh actually never mind, k can be pretty big. So then, oh wait, but n is at most 30, so there are only like a few interesting, there'll only be a few interesting points that we can choose. Alright, so let's think about this. If we have 2 tickets, if you know that these 2 are sold already, I think that we'll only choose the one before it or the one after it. This is like the number line. So, because if we choose somewhere in the middle, then will we ever choose somewhere in the middle? That could be possible, yeah. Actually, if you want to maximize the chance, I don't think it matters where you pick inside the middle. Does it? Okay. So you have to either tie or you can also tie, right, with both of your tickets. If one of your tickets is strictly closer to C than all other tickets, or if both of your tickets are the same distance to C and closer than, okay, so you have to be strictly closer. So let's say we 2 tickets have already been bought, 1 and 6. If we choose 2, then we can only win if, we can only win if the chosen ticket is 3. And if we choose 3, we can only win if the chosen ticket is 4. If we choose 4, it only happen if it's 3, and yeah, so on. What about if the distance is even? We choose 2, then these still work. Choose 3, then 2 won't work, 4 will work, but 5 won't work. Okay, and if it's 1 to 8, then yeah, it'll still be 2. To 8, if we choose 2, then 3, 4, and then 5 is right in the middle. If we choose 3, then get 4 and 5. Okay. So it'll be the maximum number you get is like D. D will be the difference between the 2 tickets. D minus 2 divided by 2, floored, I guess. Let's plug this in. Difference here is 5. 5 minus 2, 3. Floored, that's 1. You put 6 inside, it gives you 2. If you put 7 inside, it also gives you 2. So that formula seems to work. And then if you want 2 tickets in the same you put 2 tickets in the same gap, then obviously just pick these 2, then you get pretty much everything inside. So then you get D minus 1. Right. You get 2, 3, 4, 5, 6, 7. So you get 6. Yeah. Oh, and then there's also the edge case. So if you're on the edge, then let's say this is 5, and then there's no 1, 2, 3, 4. Then you just pick 4, which is directly to the left of 5. Okay, I think this should be pretty simple to implement. So what's the input? N and then K. And then we have P. And P, we should sort P. We can resize it so that all entries are unique. Would that help? Maybe. And then just loop through everything in P. So let's generate this thing called a end. Also, since we're outputting doubles, I'll add this line over here. I don't know if it's necessary, but whatever. So initially you get P of 0 minus 1. Then if size of P is greater than 1, then wait, actually we can just put it in, so and then K minus the last element of P. And what else? You also have I'll create the answer variable here. And then this should be the answer, which is just like answer divided by K. And we loop through everything. And we use the formula, which is the floor of D minus 2. So P of I minus P of I minus 1 as a distance, and we subtract 2 again. What would happen from this? It would give 0, right? I don't think it would be chosen anyway. Okay, and then you can sort all of A, and then just choose the top 2 options. Yeah, basically, answer would start at A of the greatest 2 options. So the last 2 indices after we sort them. Now we also need to check can update answer with D minus 1. So Why size of A? It's size of P. P and then, so P of I minus P I minus 1 minus 1. That seems to be good. 0.5, 0.4. Okay, something seems to be off. Wait a second, why is... The distance should be 7. Should be up there with 6. Oh, never mind. This is the... These are the actual tickets. So how do you get 0.5? So distance minus 2. This gives 1 and then purchase 4 and 8. Wait, if the distance is 4, you can actually get more. What? Oh, you also get yourself. Okay. So then it's like... So then it's just this without the minus 2. 4, 0.0, and 0.25. We kind of just make sure there are no overflow. Shouldn't be. Its distance is divided by 2. Shouldn't overflow. Everything should be good to go, I think. This is 2 then. Yeah, we add 1 in between. Okay, let's submit this and see what happens. Okay. Any judgment? People have already submitted that. Yeah, I was kind of slow on that for some reason. Interesting. Positive integers. Okay, cool, this passed. Find the next roaring year. Huh. How many roaring years are there? I think we can brute force based on the number of starting digits, I guess. Tomato, okay, 2 or more. Okay, and then they give a hidden verdict, which is kind of evil because you can imagine some errors happening. So can you guarantee that we must have the same number of digits? Or like just, Or we can only add another digit and be fine. If the number of digits is odd, then what is this? If the number of digits is odd, say we have 69324, then we can basically just do 100 101. That's an upper bound. Then what if you have like 69324 then you could do a similar thing, but this is kind of wasteful. You could just bound it by 998 999. Unless everything starts with 999, then you can't use this. And then you have to overflow to more digits. I mean, you could always just do 1, 2, 3, 4, 5. I don't think that's the most optimal. Well, let's say the first digit. Let's say we set the first digit to be the first number to only have one digit. Then can we determine the minimum? The least next Roy number. How many rolling numbers are there anyway? There can actually be a lot. Yeah, never mind then. You might overflow once, so number of digits and the numbers might increase once, but you can't increase twice. Okay, that's helpful, I guess. Use binary search if we want to. No, we can literally just max stuff together. That would work. We can just assign, wait, let's make a special case for 10 to 18. So in that case, I think it's, you have 10 to the 9 concatenated with 10 to the 9 plus 1. Yeah, that has to be the next best. Is it? If 2. I don't see why it isn't. So it probably is. Wait. No, that means it has 19 digits. Like, it has 18 zeros then. So that's 19 digits, so it's not this. I have a general brute force idea, but brute force by the number of, say these are d plus 1. How many of these d plus 1 do you want? And how many d's do you want? Okay, then we can iterate through d. Okay, yeah. I guess. Okay. Let's try to implement this. Just put in calc. That's because I want to do some testing, so 2018. 2018 minus 1. Yeah, I'll just output those and see. You have at most 19 digits. So I don't think we'll ever use more than 19 digits, so d plus 1, so 1 less than or equal to d plus 1 less than or equal to 9. Yeah. It's equal to, so let's just put this here. Set to infinity first. Now we can min it with a bunch of stuff. Alternatively, let's write alternatively we can have C2 be 0. And then yeah. So then it would be like this, I think. I think we don't need that many. Will you ever need d equal to 9? If d is equal to 9, well, if C2 is 0, then you have yeah, you might need it. Okay, whatever. And then we should call test something. While C2 times D plus 1 is less than or equal to 19. We test with like this and then X something, C1 and then C2. So what should C1 be? Need at least the same number of digits. So let's calculate the number of digits. So then add one to number of digits and then we divide by 10. Okay. Well, C1 plus D times D plus C2 times D plus 1. Well, this is less than the number of digits. You have to increase C1. A special case where you might need C1 plus 1. Yeah. How do you put D in there? Okay, so then you have to make sure this doesn't overflow. So if C1 times D plus C2 times D plus 1, if that's greater than 19, then we'll just return. Now we don't have two numbers, so if it's less than 2, then we also return. What else is there? There's some impossibilities that are involved here. We extract the chunks of the number and somehow process them. There's min start. Has to be at least 1, and then max start, which is if range, if there's no range, then we can return. Otherwise we construct a number, and then we update it with the answer. So let's try to construct a number. Current answer starts at 0. Multiply by 10, and the time complexity of this shouldn't be terrible. Yeah, it should be fine. So calculate P10 just to make it a bit faster. which is like the power of 10. So CA times P10 plus, what do we add? And S. We increment this. C2. Actually, P10 should be calculated pretty early because we'll also need that. Times 10. Plus this. Okay. That'll construct the answer. So now you have to actually find the minimum start and maximum start. Also have the accumulated power of 10. Just call that PP. Okay. We'll start from C2. And this should increase by this much. What else is there? We should find the current number mod that divide by PP mod this. This will give us that chunk that we want. And then what do we do with this? So need let's also get the index of like the chunk ordered from left to right. So the starting index will be C1 plus C2 minus 1. Want minimum start. Want to start plus index because it increments by 1 to be must be a certain number of digits long. Must be d plus 1 digits long, at least. So we want this to be greater than 10 to the power of d. And less than 10 to the power of d plus 1. Okay. We also need this to be greater. Oh, you want the next one. Okay. I'll just add 1 to y. And then that should be good. For the code, I'm just finding the first one that is either equal to or greater than. Okay, so then this also has to be greater than or equal to chunk. Yeah. So we obtain s is greater than or equal to max 10 to the d chunk minus index. So min s is a factor from this. We max it with maximum of 10 to the d, and then chunk u min this with, so then this will be less than or equal to 10 to the d plus 1 minus 1 minus index. Okay, so p of 10 times 10 minus 1 minus index. Cool, and now we just copy this and do a similar thing for the other parts. So divide by 10 here, we divide by 10 here, divide by 10 for the P10. Okay. Yeah, I think this seems about it. ND was not declared in the scope. Okay. Let's see. Okay, nice. So somewhere things messed up. How do I debug this? This is kind of hard to debug. Okay, let's debug here. We'll have x xd c1 c2. So put these here. It's actually going to be a lot of output. It's fine. Okay. This is good, right? 9 digits here, and then you have 10 digits here. Okay, so it's 19 digits. Yeah, this. 92. Okay, that's actually a problem. Do I have unsigned longs defined? Because that'd be useful here. Current answer. I can just, yeah, I'll just make that an unsigned long. Okay, yeah, that wouldn't work. Problem is this could overflow, and that would not be good. I can do something. I can, if C is greater than, yeah, I can do this. And then I still need to cast. I think you can compare these two, right? No, just to be safe, I'll cast this. Did I ever define UL? No, I did not. Maybe I could have just used, okay, whatever. Let's make sure this works. Maybe it is going to work. Okay, I need to remove the debugging output. It seems like everything is fine so far. Wait, what? Okay. Two zero two one 2122. These work. Is this actually the right answer though? Let me do 789 788. Nine oh nine 910 12. Oh shit, okay, I messed up. 11 12 234 9899. Okay. 099. These are actually good test cases. I'm actually surprised this is actually minimum. Is this actually correct? Wait, can you start out with 10? No, you can't, because you can't. So 19 is a prime number, and then you can't actually get it to overflow. So that wouldn't work. So I think this code is good, but I'm not sure if there could be any other overflow. I'll just review this one more time. This seems good. Have reached it so that number of digits match, and then also maybe you want to add an extra digit. And then get the chunks, the math looks okay, I guess. Okay, and then this won't ever exceed. Wait, could PP exceed? Could go to 10 to the 9, actually. That's not good. Does it matter? How about let's just divide x? Yeah, let's just divide x. So I'll just remove PP and then everything looks good. Just test it one more time. Okay. I don't think anything else should overflow. Oh yeah, the limit's on the digits. Don't go to D. Yeah, I don't need to go to D equals to 10. D equals to 9. Yeah, I don't need to go to D equals to 10. This is unsigned long. So this should all be This should all work well without any mistakes. Let me just cast it because I'm afraid. But this is already unsigned long, so then. Wait, what does it cast it to? I don't want it to like mess up. I guess I'm doing this. I can just look back later and see if it actually did matter. Right now, I don't think I'm taking this risk. If this passes, then I think I'm good to submit. Submit. But some people are actually done with everything, interestingly. Or maybe they just solved the easier test cases. Sample failed? Huh. Two 2021 2122. Is it not like the debug flag? Oh, it does not debug. Okay, I don't think that should count as a penalty though. Okay. Integer, I sent all integers again. Double value, take the bitwise not. So experience 12. Okay. 0 becomes 1. Unnecessarily leading zeros. Interesting. This becomes 0. This becomes 1. Ah, interesting. Wrong answer. Okay. This is not good. There's no way I didn't catch this. Are there any edge cases? 12. Yeah, I guess. 23. That's correct. Oh, you can't start with a 0. Oh yeah, but I took account of that. I took care of that. Actually don't know what else could go wrong then. Oh yeah, I actually don't know what's going on. Should I write a brute force solver? Is this good? Cannot use a leading 0 to write. Okay. 101. Yeah, I solved that. Well, yeah. It has to be positive, so it can't be 0, 1. So when it's giving wrong answer and... Okay, I don't know how to solve this. Oh. Interesting. Okay, maybe this part messed up somehow. I want the number of digits. So then... This should give me the number of digits. You need at least... yeah. There are cases I didn't take care of. Increase C1, well. Oh, okay. Can this ever give less than 2? It could. Then this should be at least 2. Both of these are 0, then yeah, just it has to increment. What constraints are there? Has to be greater than or equal to this. Oh wait, it doesn't need to be. Oh shoot. Doesn't have to do that for all chunks. Only like, you just need at least one chunk too. Then the rest of everything beneath can. Okay. So I see why it's greater now. So we can actually specify like a chunk ID, chunk index. Name this test 1. Now one of these chunks has to be greater. Okay. Oh, you have CI in here, okay. So dex is equal to CI, then need +1. Let me just separate this. P10. If it's greater, then you don't really care, okay? It's less than, then you just need to be equal or greater. So which problem does it solve? Wait, there's no way it already solves this. Wait, what? Because it constrains it to be, has to be greater than the chunk. But 780 is not greater than that. Oh, that's because I added 1 before, okay. Okay, yeah, this, and then this messes up. This works. Let's make sure that case works. Nice. Submit this. Hopefully, I don't think it'll TLE. Like, number of digits is really small, so iterating over these should be fine. Okay. Then I have no idea how many of these people are. Okay, pass. I'll just assume it passes. Okay, no idea how many of these people actually solve both of these. It's hard to tell. Okay. Do I get 2 penalty? 104. Wait, that's 1 penalty. Okay, minimum number of transformations, 100. Doubling, you basically add a 0 to the right. You can only do it to us, right? I don't think you can increase the number of sections. Let's take S, let's add a 0 to the right, and let's try to find the number of sections. I'll just keep this for now. So S will be like continuous chunks of 1s and 0s, and that's 0 since we added that. This will be the maximum number of sections we can ever have. Okay, and then so if E somehow has more sections, say E is 101010, then we're screwed because we can never create 3 copies of like segments of 1s or 0s. We try to add 1, and no, you add 0. You can try to invert, but then yeah. So do we just compare the number of 1s? There are also cases if S or E are 0. And I have to take care of those because it seem like they may be troublesome. Can they be the same? Oh yeah, they can. Okay. So do we just compare the number of 1s? But, oh yeah, the argument is that okay, if S is 0, if S is 0, if S is 0, then the only types you can get are like these. If S is 0, if S is 0, you have to start by changing it to 1. Okay, so that takes care of, unless E is already 0. Okay, S0 change to 1. If E0, what's the last move that you have to do? If E is equal to 0, we can change E to 1. No. E can be any anything with like continuous 1s. Like E equals 0 will be a separate case. Let's just start. Yeah, I'll start writing the input. Are there actually only 3 problems? Okay. So we take in S and then E. S is equal to E, then print 0, and then yeah, that's it. Otherwise, if E is equal to 0, what do? We have to change everything to 1s. Base is just not. So we not, and then not, and then not. But then there should be no point of adding zeros. I don't see the point of adding zeros. That just makes your life hard of doubling. And then if you start like this, then not, and then you not. You start like this, you not, and then not. V is equal to, doesn't that V equal 0 case? Okay. Use single quotes because I got confused with JavaScript anyway. Just find the number of sections, -1, and then that's the answer. Okay. Yeah, that makes sense. Because each time you not, the number of sections decreases by 1. Actually just XOR them, and then that's the number of changes, so I'll just print C and I'm done. Let's try this. So 2 0 101 0. Oh no, that's not 0. Okay, so it should be C plus 1. 0 101 0 101 0. So this is 101 101, and change it to 0. I'll just make sure that you can't change E. S, transform S into E. Yeah, okay, I think that takes care of the equal 0 case. Okay. S is equal to 0. First move is to change S equal to 1. Okay. So now we have to detect if it's impossible. And how do we do that? Also, S can be equal to E now. But so let's actually try to formulate the condition for the impossibility. So number of ones cannot increase at all. Okay. Number of like 1 sections cannot increase at all. Unless you're at 0, but we already checked for that, so. What else? Is that it? Does the main if number of 1 sections? Can we always construct? Yeah, I think we can look at this as each section has a certain number. And then this one can also be 0 if if it ends with the 1s. Operations are add the last section by 1, or you can remove the first section and add the new section, which will be equal to 0. Number of 1s basically. Okay, and then this is actually an easy problem. Do not the same then. Push back 1, otherwise we add 1 to the back. We do the same thing for the ending string. Okay, so now we have the sections. Oh yeah, we can also pad it. Okay. And if the s dot back is not equal to 0, then we have 0. If e dot back is not equal to 0, we add 0. If their sizes, or if the size of b is greater. Greater than size of A. We know it's impossible. Okay, otherwise, you have a pretty simple problem, I guess. It's only 100, right? Yeah, okay. So now, we can brute force over the number of sections that we remove from A. That's answer 1. Int max. And then if size of B is smaller, then we can pad it with zeros. I think this will change it. Yeah, it shouldn't change. Well, size of B is less than size of A. Let's pad it with a bunch of zeros. Let's brute force over how many you want to remove. Have to make sure that after we shift it, everything is aligned. If they're not the same, so if EFJ is not equal to AFJ plus I, then yeah, then it's bad. I assign all the way to n. We add EFJ, and then min ans 2 with current answer. Let's see how this does. 7, 7. Huh. Change it to 1, 1, 1, 0. Oh, you can still change the last one. Okay. Well, in that case. Wait. Oh wait, if you, okay, sure. If it ends with a 1, so if f is equal to 0, then you can actually remove both of these at the same time. You can remove a and f if f is equal to 0. Okay, that's a bit weirder. That means you probably don't want to pad B with zeros. We'll still add this, so what are the states? So DP removed in the front, and then how many you have removed from the front, and then How many added or removed? How many you have fixed from the suffix? Okay. If you remove something, then technically you wait. I don't think this will work because if you shift stuff around, then things are going to change. So I think in the beginning you have to already know how many you want to remove from the front. Will you always remove stuff first? Because if that's true, then in this test case, you didn't remove a section, technically, because there's a 0. In what case would you not remove sections first? So if you don't remove sections first, what do? Basically add new sections. So these are original sections, you add new sections. Similarly, you want to remove these. Similarly, you try to remove those at the end. Which doesn't really make sense, I guess. Because you remove all you need first. And then yeah, I think you need to remove the sections in the front no matter what. So If S is already 0, then take one move to move these two. But if it's not 0, then take 2 moves to remove these two. Yeah, you wouldn't. Okay, so you do remove stuff already. Okay. If the back is 0, okay. So I'll move it over here. And for here, you just raise. Okay, you should get something. Okay, these two should have the same size now. They have the same size. Now what? Now you might want to remove more. So then you just use the same algorithm. So how much do you actually remove? Okay, last one. So j plus I, it's not equal to b less than. So if it is n minus 1, if it's the last element, then we can always add more. So we just need, this only fails if minus 1. Only fails if this is greater than, yeah. We add if j minus I minus 1 minus if minus 1. I need to test this part carefully. Negative numbers. Where did that come from? Four, 3, 2, 1, 0. If I is n, then oh yeah, if I is n, then too bad. If I is less than n, how we do this? If I is equal to, if we move everything, then don't really care. Wait, what do we move everything? Right. Alright, so what if will you ever choose I equal to n? Yeah, possibly. Yeah, we could. And construct a test case. 110. 100. 111 where everything is just different. Oh yeah, we can add 1 to this and then we switch 3 times and get that at 15, okay. We just modify this test case a bit, add 2 more zeros here. Now it should be much more, 24. So you have to move everything S4 and you have to add those, okay. Guess that makes sense, I'll submit it right now. So I took about like 90 minutes to finish everything. I feel like someone could be faster. I feel like there are definitely people who it's really easy to get easy test cases, so nobody actually knows if they passed or not. Okay, cool. I think this should get all correct on the hidden tests. I don't see a big difference between like, actually there could be a big difference. Okay, not sure. I just have a feeling that after well, yeah, I just have a feeling that when the actual results come out, there are going to be a lot of changes, since I feel like a lot of people are only solving the small cases. It makes sense given that the small cases are much easier. Okay, cool. So I guess now we just wait, or I could also try to, I guess I'll just try to debug I'll try to check my solutions against brute force. Seems like a good idea. I'm gonna take a break first. Okay, actually I'm too lazy, so I just kind of don't want to check, and I feel like Google Code Jam tests are pretty good, so there's really, I don't think there's that much of a point in trying to write brute force. And yeah, even if I miss these 2 subtasks, I think everything else still will be able to move on to the next round. So yeah, it's not too important, and I'm just lazy, so I'll see you guys when the leaderboard opens, when the full results come out. Okay, so right now I'm 150th place, so a lot of people in front of me have resubmitted, but I think after the results are revealed, I'll probably move up even further, unless I fail one of them. If I fail one of them, then it depends. Okay, let's see where that takes me. Oh cool, I got all of these, and that puts me at 13th, all the way from 200 place to 13th, so not bad, but I think I could have done some of these a bit faster, but oh well. Still got a perfect score, which is not bad. Okay, so I'll definitely be back for round 2.